కనిపిస్తుంది సార్.
Okay, this is current electricity. Okay, now the time rate of flow of charge I is equal to dq by dt.
Yes, sir.
Current is equal to rate of flow of charge. Okay, this current you say this is average current. I average is equal to dq by dt.
DT. Yes, sir.
Okay, if you want instantaneous current, in that means current at that particular time, then I instantaneous is equal to a limit delta t tend to 0 dq by
DT.
dt.
Yes, sir.
Okay, so now if this is a conductor and this is a conductor, then charges, if you apply potential difference, okay, say this is negative and this is positive. If I apply potential difference, then the electrons will start moving in this direction
Yes, sir.
towards the positive terminal. Okay,
Yes,
or
yes,
else they will be moving in metals, they will be moving randomly, so the net charge flow will be equal to 0.
yes,
But
sir.
now if you consider a cross section, then the number of electrons which are moving in this direction will be more. So we say this is electronic current.
Yes,
Now
sir.
if this is in the direction, if this is the direction of the electrons, then this is the direction of the current.
Current. Yes, sir.
Okay, the electric current direction is taken opposite to the direction of the motion of electrons,
Electrons. Yes, sir.
right? Okay, and current is a scalar quantity. Current
Scalar quantity.
is a scalar quantity.
Yes, sir.
It has magnitude, it has direction, but still it is a scalar because it doesn't follow vector laws.
Yes, sir.
Okay,
Yes, sir.
now current through a conductor of non-uniform cross section. So I'll consider a non-uniform cross section. Okay, non-uniform cross section. So first I will pass through this one. Okay, and bigger area of cross section I will consider. So this is a bigger area of cross section.
Yes, sir.
Still bigger area of cross section I will consider. Okay. Now here you can see here. Now if the current here in this is current here is I1,
Yes, sir.
then current here is let us take this is I2 and current here is
I.
I3. We
Yes, sir.
write current is I1 is equal to I2 is equal to I3.
I3.
Current
Yes, sir.
okay, current will be same.
Same. Yes, sir.
Okay.
Yes, sir.
So for a given conductor, the current does not change with the change in the cross section area. Okay.
Yes, sir.
Now there are two types of current. So one is AC current, AC current. Other one is DC current.
Current. Yes, sir.
Okay. Now here we discuss mostly on DC current. So current electricity, I can call it as DC circuits also. Okay.
Yes,
When
sir.
it AC, we will discuss in a separate chapter.
Yes, sir.
Alternating current or AC circuits will discuss separate chapter.
Yes,
So
sir.
current electricity means basically we are discussing about the DC
Current.
circuits.
Yes, sir.
Okay, DC current or DC circuits. Alternating current means the current will be like this. Okay,
Yes, sir.
positive cycle, negative cycle.
Yes, sir.
DC current is like this. Okay,
Yes, sir. Yes, sir.
right. Now, okay. Now, next concept is current due to translatory motion of a charge. So now, if you consider an area of cross section, if in this direction positive charge is going, then we say that is the direction of current.
Yes, sir.
The direction in which the positive charge moves, that is the direction of current.
Current. Yes, sir.
Okay. So if n particles are moving, then I is equal to n into q.
Yes, sir.
Okay, say if n particles are moving, then the total charge will become
I.
I is equal to total charge is nq. I is equal to q by t na. So total
Q.
charge is
I is equal to Q by T.
q by t. But the total charge n charges are there. So n into q.
Q. Yes, sir.
So I is equal to q by t. That is equal to nq.
Yes, sir.
Okay. Nq. See if n particles each are having a charge
Yes, sir.
q pass per second per unit area, then current in that is equal to nq a. Okay,
Yes,
this
sir.
is per second.
Yes, sir.
Okay, right. Now
A is
due to,
area.
yeah, a is area
Yes, sir.
through this area. This is the area of cross section.
Yes, sir.
That's the area of cross section. Okay. Now rotatory motion of charges. So charge is moving in a circular path. Let us imagine that electron is moving about a charge.
Yes, sir.
So about a particle, this electron is revolving. Then how you are going to write here? Now here I is equal to charge is equal to q by t, but
Yes, sir.
1 by t is equal to frequency.
Frequency.
So q into frequency is nu.
Yes, sir.
Okay, 1 by t is frequency. So q,
Q new.
so q nu.
Yes, sir.
Okay, this is time period, na?
Yes, sir.
Time period is equal to t is equal to 2 pi r by v.
Yes, sir.
V is velocity here.
Yes, sir.
V is velocity with which it is traveling. Here V is velocity.
Yes, sir.
So I can write here Q by 2 pi r by V.
P. Yes,
So
sir.
that is equal to QV
QV by 2
by 2 pi
by R.
r.
Yes, sir.
Okay, you have to remember this V is
Velocity.
velocity,
Yes, sir.
and here nu is
Frequency.
frequency,
Yes, sir.
and that's the radius r.
Yes, sir. R is radius.
R is
Radius.
radius.
Yes, sir.
Okay, I can use another formula. T is equal to 2 pi by omega. So
Yes,
I
sir.
will write here in place of T 2 pi by omega. So it is 2 pi by omega. So
Yes, sir.
I is equal to Q omega by 2
2
pi.
pi. Yes, sir.
This is okay. So this is charge in rotatory motion.
Yes, sir.
Okay.
Yes, sir.
Right. Right. Okay. And now, okay, done.
Yes, sir. Yes, sir.
Right. Right. Now, next idea is, now if you have a conductor, say this is a conductor. This conductor concept, let us take this concept as C3.
Yes, sir.
Now we apply potential difference. How do you apply potential difference? Connect it to battery.
Yes, sir.
Okay. Now let us take this is V. That means here you have positive
Yes, sir.
and here it is negative.
Negative.
So now you have a electric field here. So in this
Yes.
field, the electron will try to move in this direction. If electrons are moving in this direction, then
Current in opposite direction.
current is moving in opposite
Yes.
direction. So
Yes.
electrons moving. So current is in opposite direction. We write potential difference is or the current developed is directly proportional to V. V is directly proportional to I.
Yes,
V
sir.
is equal to I into R,
R. Yes, sir.
where R is resistance of the conductor.
Yes, sir.
R is resistance of conductor. Okay.
Yes, sir.
Now resistance of the conductor. Now here the condition is, now here R is a proportionality constant. I used R as a proportionality
Constant.
constant.
Yes, sir.
This is constant means temperature has to be constant. Why? Because resistance of a conductor will change. R
Yes.
is equal to R naught into 1 plus alpha into delta T. Okay, so if temperature is constant, then R is
R.
equal to R naught. That means resistance will be constant. So that's why this is called as Ohm's law, and the Ohm's law is valid only when the temperature is constant.
Yes, sir.
When the temperature is constant, because if the temperature is constant, then only R is
Constant.
constant.
Yes, sir.
Okay, this is called as Ohm's law.
Ohm's law.
Now here it is very important that Ohm's law is valid only when temperature is constant, because then only R is constant.
Yes, sir.
Okay. Now from here the current I is equal to V by R.
R.
Okay, we are discussing about current.
Yes, sir.
Okay. Then we go for another concept called as current density. Current density. Now this current density is denoted by capital J,
Yes, sir.
and this J is a vector quantity. J is equal to, what is J? J is current density.
Yes, sir.
Okay,
Current density. Yes, sir.
current density. Current per unit area. This is current per unit area. dI by dA.
Mm, mm. Yes, sir.
Current per unit area.
Unit area. Yes, sir.
Okay. Now say you consider a conductor,
Yes, sir.
then the current is I, and this area of this cross section is A.
Yes,
Then the
sir.
current flowing per unit area is called as current density.
Current density. Yes, sir.
Okay, J will have same direction
Yes, sir.
as that of current.
Current. Yes, sir.
Okay. Now, if the area of cross section is say like this, okay, then area is in this direction. Okay, the
Yes,
direction of area is always perpendicular to the surface,
yes,
and
sir.
J direction is in this direction. So let us take
Yes,
this is the angle
theta.
theta.
Yes, sir.
Theta. Then we will write J current density is equal to, let us take that current dI is flowing through that by
Yes.
dA
Cos theta.
cos theta, or else you can write J dot dA is equal to dI.
D.
Now
Yes,
you
sir.
can put integral J dot dA is equal to I.
D. Yes, sir.
Okay, integral of dI will become I.
Yes, sir.
Integral of J. Now this we can write it as dA
Cos theta.
cos theta is equal to
I.
I.
Yes, sir.
This is another important concept. Okay,
Yes, sir.
right. Now current density is a vector quantity. Okay, and its unit is ampere per
Meter. Meter square.
meter square.
Yes, sir.
Right
Yes, sir.
now, now, right, current density in terms of electric field. In terms of
Electric.
electric field. Okay. Now current density is J is equal to sigma E. This is another form of Ohm's law.
Yes, sir.
Okay. Where sigma is, what is sigma? Conductivity.
Yes, sir.
Sigma is
And the.
conductivity. And rho is resistivity.
Yes, sir.
Rho is resistivity and sigma is
Conductivity.
conductivity.
Yes,
J
sir.
is equal to sigma E. Okay.
Yes.
Now conductivity and resistivity, the relation is the conductivity is equal to 1 by resistivity.
Yes, sir.
Okay. So we write J is equal to sigma is 1 by rho. So it will become E
E
by
by.
rho.
Yes, sir.
Okay. Now the direction of current density is same as that of electric field.
Yes, sir.
Okay. Now, okay. Right. Now, okay. Now this we call it as E4, na? Current density C4. Yeah.
E5.
Now we will write C5.
Yes,
C5 is the next concept which we call it as drift velocity
yes,
or
sir.
drift speed. Okay, drift velocity or else drift speed, both
Yes,
are same. Okay, this is Vd,
yes, sir.
denoted by Vd. Okay,
Yes, sir.
now you take a conductor. You take a conductor of uniform cross section and you apply field. Field means we will connect a battery to it, then electric field is established in this.
Yes, sir.
Now when it was going, so this is positive and this becomes
Negative.
negative.
Yes, sir.
And the electron is going to move from here to here in this direction.
Yes, sir.
So when the electron is moving in this direction, it hits with the positive ion cores.
Yes, sir.
Then it loses all the energy. And again, due to the attraction, again it accelerates.
Yes, sir.
Then again hits the positive ion cores and again loses its energy and again accelerates
Yes, sir.
in this direction.
Yes, sir.
Okay, the average velocity with which it traveled, we call it as drift velocity.
Velocity. Yes, sir.
Okay, the average uniform velocity acquired by the free electron inside the metal by the application of electric field.
Yes, sir.
Okay, it's called as drift velocity. It is
Velocity.
very small, right? 10 power minus 4 meter per second. Okay, drift
Yes,
velocity is small. Okay, now, okay, so this is the uniform velocity or average velocity acquired by the electron
yes, sir.
when placed in the electric field
Field.
is
Yes, sir.
called as drift
With
velocity.
velocity.
Okay, now we have few formulas for this. I is equal to I, current I is equal to N, number of electrons or
Electron. Yes, sir.
number of electrons, E, charge of the electron, NEA
Yes, sir.
VD is the formula. I is
Yes,
equal to NEA VD.
VD. Yes,
VD
sir.
is the drift velocity. Drift velocity is equal to I by
I by NEA.
NEA.
A. Yes, sir.
So here you have to remember this formula. Okay. Now here you can we can see that this I by A we can write it as J.
J. Yes, sir.
So J by
NE.
NE,
Yes, sir.
that is equal to J is equal to sigma E. So I'll write
Sigma. Yes,
sigma
sir.
E
By N.
by NE,
NE. Yes, sir.
that is equal to sigma is 1 by rho.
1 by
So I
rho.
can write
E by
E by
rho NE.
N E
Rho.
rho.
Yes, sir.
Okay.
Yes, sir.
Then V is equal to um, E, V is equal to E is equal to V by L
E by
or
L.
V by D.
Yes, sir.
So V by V by
NE.
N E
Rho
rho
L.
L.
Yes, sir.
Okay, this many formulas we can
There are.
write.
Yes, sir.
Okay. Now, important in this is the relations actually here.
Yes,
Now,
sir.
this VD is directly proportional to E. You look here. This, watch
Yes, sir.
this.
Yes, sir.
This step. This step. Now, VD is directly proportional to E.
E.
So,
Yes.
electric field is more, then
Velocity.
the drift velocity will be more.
More. Yes, sir.
Okay. Another one we can see here, VD is inversely proportional to A.
A.
Here
Yes,
you
sir.
can see.
Yes, sir.
Okay. Based
Yes.
on this concept, he will give a question that now he will give a question like this.
Yes, sir.
Current I is flowing through this one. What happens to the VD at A and B? Where it will be more?
A, sir.
At A.
Yes, sir.
Okay, A area of cross section is less, that means VD
VD
is
is more.
more.
Yes, sir.
VD drift velocity at A
Is
is greater
greater.
than drift velocity at
B. B.
B because
Yes,
this drift velocity is inversely
inversely proportional
proportional
to A.
A.
Yes, sir.
Okay, the time difference between the time interval between two successive collision of electrons with the positive ions is called as relaxation time.
Yes, sir.
Tau. Okay, tau is the time interval between two successive collisions.
Yes, sir.
Okay. Now, another important point here we write is mobility. We have something called as mobility. Okay, mobility.
Yes, sir.
Generally, it is denoted by mu.
You.
Okay, the
Yes, sir.
mobility is drift velocity per unit electric field.
Yes,
So
sir.
when you have an when you see VD is directly proportional to E increases, VD increases.
Yes,
So
sir.
when electric field is 1 unit, then what is the drift velocity? That is called as
You.
mobility.
Yes, sir.
Mobility. Okay. Unit is meter
Sir.
square by volt second.
Yes,
Okay.
sir.
This for mobility.
Yes, sir.
Okay, if a problem is there, then you should see that in which concept it is from, whether it is from C1, C2, or C4, or C5.
Yes, sir.
Okay,
Yes, sir.
that is about drift velocity. Now, what we are going to discuss is Ohm's law. Again, come back to the Ohm's law. Now, we will discuss that in bit detail. Ohm's law is C4, right?
Yes, yes, sir. C4. Yes, sir. Current density is C4, sir. C3 is Ohm's law.
Yeah,
Yes,
yeah.
sir.
I just discuss more about this Ohm's law.
Yes, sir.
C 3.1.
Yes,
Okay.
yes, sir.
Now V is equal to IR.
Yeah.
Okay.
Yes, sir.
Now this is Ohm's law. Okay, where R is a proportionality constant called as resistance.
Resistance.
Resistance, which is constant.
Yes, sir.
Which is constant. Constant means that means here the temperature is going to be
Constant.
constant, because if temperature is constant, then only resistance is
Resistance is constant.
constant.
Yes, sir.
Temperature is
Constant.
constant. Constant. That's important point.
Yes, sir.
Okay, but this is not universal law. Universal law means say all the quantities, all the substances are not going to obey Ohm's law.
Yes,
The
sir.
substances which obey Ohm's law are called as ohmic
Ohmic
conductors.
conductors. Yes, sir.
Ohmic conductors are those conductors which obey Ohm's law.
Yes, sir.
Okay. Now, if you obey Ohm's law, then if you draw a VI characteristics, potential difference, and current characteristics, that's
Yes,
potential, and this is current, then you will get a straight line because it is a direct relation. Na?
yes, sir.
So this is theta there.
Yes, sir.
Okay. Now, here tan theta is equal to what is tan theta? Tan theta is equal to V by I. V by opposite side by I.
Yes, sir.
So it is V by I.
I.
Okay.
Yes, sir.
Tan theta is equal to V by I, which is equal to
R.
R.
Yes, sir.
Okay. Now let us take another one, another graph. Now that's V.
I.
That's I. V in this direction.
Yes, sir.
Oh, okay.
Yes,
So now at two different temperatures if you take, so that's one
T1.
that is T1
Yes, sir.
and this is
T2.
T2.
Yes, sir.
This is T2 is theta
Hello.
2
Yes, sir.
and T1 is theta
1.
1.
Yes, sir.
Now here tan theta 1 is greater than
Tan theta 2.
tan theta 2. That
Yes,
means R1 is greater than
R2.
R2 because if the temperature increases, then resistance
Resistance
increases,
increase. Yes, sir.
right?
Yes, sir.
Now, if which doesn't follow Ohm's law are called as non-ohmic
Non-ohmic conductors.
conductors.
Yes, sir.
Non-ohmic conductors. Okay, these basically are metals.
Yes, sir.
Conductors, ohmic conductors are
Metal.
metals basically. And non-ohmic conductors are different types like triodes, diodes, semiconductors,
Insulators. Yes.
semiconductors, diodes,
Yes, sir.
uh,
Triodes.
and yeah. So this will have different shapes, okay? Different
Yes, sir.
shapes it can have like this or okay. So it will have different shapes.
Yes, sir.
Okay, can have different shapes. Semiconductors, diodes, valves,
Yes,
different
sir.
things. Okay, those are
Non-ohmic
non-ohmic
conductors.
non-ohmic conductors, and it won't be a straight line. Okay,
Yes, yes, sir.
right now. So I'm going to discuss about resistance now.
Yes, sir.
Okay, so C6.
C6. Yes, sir. C6.
Okay, resistance. Resistance is a property of the substance by virtue of which it opposes the flow of current. Okay,
Yes, sir.
so now the so if you consider a conductor, say this is a conductor. Okay,
Yes, sir.
right. This is a conductor. Now you pass current through it. Okay, let us take I current is passing through that conductor.
Yes, sir.
When I current is passing through this conductor, then the resistance. Okay, now yeah. So it offers some resistance. The
Resistance.
conductor offers some resistance,
Resistance.
and it will depend upon the length of the conductor, the
Yes, sir.
area of cross section of the conductor.
Yes, sir.
Okay, so now the resistance. Now what we are discussing is resistance of the conductor.
Yes, sir.
Now, resistance is directly proportional to length of the conductor. Resistance is directly inversely proportional to
Area of the
area
conductor.
of cross section. Then resistance is equal to some constant rho into
L.
L by
A. A.
A.
Yes, sir.
R is equal to rho L by
A.
A.
Yes,
Where
sir.
rho
Conduct.
is called as resistivity.
Resistivity. Yes.
Resistivity. Sigma is called as conductivity.
Activity. Yes,
Rho
sir.
is called as resistivity.
Resistivity.
Okay. Now the resistivity. See, if you take this as one and this as one, R is equal to rho.
Yes, sir.
R is equal to rho
Ro-
when you take the length as 1 meter and
Area.
area as 1
1 meter
meter
square.
square. That
Yes,
means
sir.
you take a rod of length 1 meter, of
Yes, sir.
length 1 meter and 1 meter square area of cross
Area.
section,
Yes, sir.
then the resistance offered is called as
Row.
resistivity.
Yes, sir.
Okay. Now, what does that mean? That means resistivity of a material is constant. Say, row of aluminum is different, row of copper will be different. So,
Yes,
different conductors will have different resistivity. Okay.
yes, sir.
And resistivity doesn't depend upon the length. Why? Because resistivity is already defined per unit length and unit area of cross section.
Yes, sir.
Okay. So, resistivity doesn't
Length.
depend doesn't depend doesn't depend on, simply put I will write dimensions of the body. Dimensions of the body means it doesn't depend upon
Length, area.
length and
Area.
area.
Yes,
Okay,
sir.
it doesn't depend
Yes, sir.
because it is defined per unit length and unit area.
Area.
It depends upon the nature of the material only.
Yes, sir.
Okay. And resistivity also changes with temperature.
Yes, sir.
Changes with temperature. Rho is equal to rho naught into 1 plus alpha
Alpha delta T.
delta T.
Yes,
So
sir.
it changes with temperature.
Yes,
It
yes, sir.
is dependent on temperature. It depends
Yes,
on temperature and it depends upon yeah, temperature and nature of the material and nature of the
yes,
material.
yes, sir.
Okay. Now, so uh, yeah. Okay, so the resistance depend upon the temperature, like resistance or T is equal to R at resistance at temperature T is equal to
R
resistance at
naught
0 degrees. R
one.
naught is resistance at 0 degrees.
Yes, sir.
1 plus
Alpha delta T.
alpha
Delta T.
delta T. Okay, now
Yes,
if it is at 0, then delta T is raised in temperature.
yes, sir.
Okay, so we can further expand this alpha into beta square or something. Okay, where alpha and beta, which we call them as temperature coefficient of resistance.
Yes, sir.
Temperature coefficient
Of resistance.
of resistance
Yes, sir.
of resistance.
Yes, sir.
Okay. So if the temperature is less than 300 degrees, if T is less than 300 degrees centigrade, which is every time it gives a temperature less than 300 degrees centigrade, so we need not go with all of this, and we can just write RT is equal to R naught into 1
1 plus
plus alpha
alpha delta T. T.
delta T, or just T is raised in temperature here. Okay, or
Yes,
else
sir.
delta T also you can write.
Yes, sir.
Okay, if you want alpha, alpha is equal to RT minus R naught by R naught into T.
Yes, sir.
This is alpha value.
Yes, sir.
Okay. Now,
Yes, sir.
if R1 and R2 were given at temperatures T1 and T2, then RT is equal to R naught into 1 plus alpha T1 by R naught into R1 R2 R naught into 1 plus alpha T2. So here R naught and R naught gets cancelled. R1 by R2 is 1 plus alpha T1 by 1 plus
Alpha
alpha
T2.
T2.
Yes, sir.
Okay,
Yes, sir.
right. Okay. next concept is same resistance. One more application we are going to discuss. Okay.
Yes.
Now that is stretching of wire. C6.1. Stretching of wire. Stretching of wire. So now if you have a wire, okay, now if you are going to stretch this wire, then let us take this length of this wire is L1.
Yes, sir.
Okay. And now you stretch it to some other length. Let
L2.
us take that length has become L2.
Yes,
Now
sir.
what happens here is the resistance is R1. Now this resistance is R2.
R2.
Now here when you pull this one and if the length increase, then area of cross section decreases because the volume, initial volume and final volume of the wire
Wire.
is going to be same. So
Same. Yes,
we write area A1 into length is L1, that is equal to
A2.
L2 into A2.
A2. Yes, sir.
So L2 will be equal to L1 A1 by A2.
Yes, sir.
Okay.
Yes, sir.
Now generally the question is basically if the length is doubled, what the length is doubled, if the wire is stretched and the length is doubled, then what
Yes,
happens to the resistance? How much will be the resistance? Okay. Now if the length is doubled, the volume will be same. V1
yes,
will be
sir.
equal to V2. If L2 is equal to 2L1, for that case I am writing.
Sir, resistance is independent of length, ka, sir?
R is directly proportional to L gadam. Length
Yes,
if length is, but here if length increased, area of cross section decreased kada kabatti resistivity is independent, resistivity
resistivity. Yes, sir. Yes, sir.
not resistance.
Yes, sir.
Okay. Now
Yes,
okay, V1 is equal to volume of this one is equal to volume of this is volume is area into length. So
length. Yes,
A1 into L1, that
L1.
is equal to area is A2 into L2. L2 is nothing but 2
2L1.
to L1. So this
Yes,
L1 and L1 gets cancelled. So A1 by 2 is
is
equal
equal
to
to A2.
A2.
Yes, sir.
So resistance R2 is equal to rho
Rho
into, so
L by
resistance R1 is rho
L by
L1
A.
by A1.
Yes,
Okay,
sir.
now resistance R2 is equal to rho L2 by
L2 A1 by 2.
A2. So this is rho into L2 is what? L2 is 2L1.
2L1.
So that is 2L1 by A2. A2 is A1 by
A1
2.
by 2.
So that is 4
4 rho L1 by
L1 by
A1.
A1.
A1. Yes,
That
sir.
is equal to 4 R1.
R1. Yes, sir.
So R2 is equal to 4 times of
R1.
R1.
Yes, sir.
R2 will become 4 times of R1.
Yes, sir.
Okay, so if it is stretched double, so it became 4. If it is
Yes,
stretched n times, so I will extend the same logic and I will write stretched to n times,
yes, sir.
stretched to n times, then the final resistance is going to be n square
R.
times of R.
R. Yes, sir.
N square times of
R.
R.
Yes, sir.
Okay,
Yes, sir.
right. This is stretching of wire.
Yes, sir.
Okay, next concept. This is about resistance only,
Yes, sir.
which we call it as color coding. So
Yes,
now when you look at the resistor actually when in the lab, it will be like this.
yes, sir.
Okay, in that you will have some strips. Okay,
Yes, sir.
so this is uh, one color, this is another color, this is another color. Okay,
Yes, sir.
so you will have different colors like this. Okay,
Yes, sir.
so now, okay, and here you will have another color. Let us call them as A. First band as A, B, C, and D.
Yes, sir.
Okay,
Yes, sir.
so A and B denotes the significant figures. First two significant figures.
Yes, sir.
They will denote the significant figures. Then the C indicates the multiplier.
Yes, sir.
C is multiplier. And D denotes the tolerance.
Yes, sir.
D denotes the tolerance.
Tolerance.
Okay, now I will tell you one simple tip to remember this one.
Yes, sir.
Now that is BB Roy, BB Roy of Great Britain,
Mhm.
of Great Britain
Yes, sir.
has a very good wife. Okay,
Yes, sir.
with as a good wife because she got a lot of gold and silver.
Silver. Yes, sir.
Okay, now I will write this one. BB Roy of Great
Great
Britain
Britain
has
has
a
very good
very
wife.
good wife with gold and
Silver.
silver.
Yes, sir.
Okay, this blue, this B is blue. Okay, this B is
Brown.
first one. B is black. I'm sorry.
Yes, sir.
B is black,
Yes, sir.
black. Then brown. Then R for
Red.
red. O, orange.
Yes, sir.
Y,
Yellow.
yellow,
Green.
green. Here blue.
Yes, sir.
So first black, then
And
brown.
yes, sir.
Okay, this one V,
Violet.
violet. Now here gray.
Yes, sir.
Here it is gray. And W means
White.
white.
Yes, sir.
And then here the A and B, for A and B we write here
Yes, sir.
0, 1. Let's change the color. 1, 2,
Two,
3, 4, 5, 6, 7, 8,
nine.
9.
Yes, sir.
Okay. So this is for both A as well as
P.
B. That
Yes,
means
sir.
if first one is red, then we will write 2. If
2. Yes.
the next one is blue, then
Yes.
we will write 6.
6. Yes, sir.
Okay, so because A, B are significant figures, so
Figure.
we will write say if a red and blue are there, red is 2, so
2.
I will write 2.
Yes, sir.
And if blue is there, then I will write 6.
6. Yes, sir.
Okay, red, blue, and then yellow. Yellow is 4.
Yes, sir.
Yellow is multiplier. Okay,
Multiplier. Yes, sir.
multiplier is here. Multiplier.
Yes, sir.
Multiplier is this is 10 power 0. Let's change the color.
Yes, sir.
This is 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8,
10
and this
power
is 10
9.
power 9.
9. Yes, sir.
So now here first one is red,
Red,
and
blue,
then next one is blue.
blue. Yes, sir.
Blue is 6. So I wrote 26.
Yes,
So
sir.
A, B I will write into multiplier.
Yes, sir.
Multiplier is yellow, say yellow
Yes, sir.
is 10 power 4.
10 power 4. Yes, sir.
Okay.
Yes,
Then
sir. Tolerance.
gold tolerance is 5% and
Yes, sir.
silver tolerance is
10%.
10%. If you are
Yes, sir.
having no color, then
Yes,
it is 15%. So if you take gold, then you write plus or minus 5%.
5%. Yes, sir.
That's how we measure the uh, resistance, color coding of resistance.
Resistance. Yes, sir.
Okay, B.B.
Yes.
Roy of Great
Of
Britain
Great Britain.
is a
Very good wife.
good wife. Okay,
Yes.
we have to use this um,
Demonic.
sequence. Then,
Yes,
yeah, mnemonic you can call. Then we can easily write the values
yes, sir.
of the resistance.
Yes, sir.
Okay,
Yes, sir.
right.